All right, this is going to be the last of our official review videos. We will be reviewing topics over the course of the semester, but this is the last one before we get started with the new material. All right, in these videos, we are going to talk about graphing, and in this one, we are going to talk about the rectangular coordinate system and plotting points. All right, so just some quick vocabulary that we want to review. The first one, when we talk about the rectangular coordinate system, this is where we graph in 2D space. And so we have the origin. This is where two perpendicular lines intersect. Each one of these lines has a special name. The horizontal line, or the one that goes from side to side, is called the x-axis, and the one that goes up and down or is a vertical line is the y-axis. The two lines divide the plane, and that's just a math term for a flat surface, into four regions that we call quadrants. The upper right quadrant is quadrant 1, and we move counterclockwise to find the others, which is quadrants 2, 3, and 4. Within these quadrants, or on these axes, we're going to go ahead and plot things called ordered pairs. And an ordered pair is a set of number, and our notation is we have x comma y separated by a comma and encased in parentheses. This identifies any location in the plane. The point x comma y is called an ordered pair because order does matter. The point 5, 2 is not the same as 2, 5. All right, so let's go over these things visually. All right, here is our coordinate axes. We have where the two lines meet is the origin. We have the line that goes from side to side, or the horizontal line. We refer to this as the x-axis. And the one that is vertical, or goes up and down, is the y-axis. We have not only these two lines, but we also have four regions. And so the top right, we refer to this as quadrant 1, and we use Roman numerals for this. If you want, you can also just say Q1. And we want to go counterclockwise, so we're going to go to the top left for quadrant 2. We're going to go down to the lower left for quadrant 3. And we're going to go down to the lower right for quadrant 4. All right, so that is basically the breaking down what things are when we talk about graphing. All right, the next thing that we want to look at is we are going to talk about plotting points in the rectangular coordinate system or in the plane. And so this is going to be pretty easy. We are going to start at the origin, which is why we call it the origin. It's the starting point. We want to move left or right based on the first number. Just like with our number line, if it's positive, we move to the right, and if it's negative, we go to the left. From that spot, we want to move up or down depending on the second number. If it is positive, we move up, and if it is negative, we move down. Once we get to our new location, we are going to plot the point, just like we did when we did the number line. Remember, you do have to put a dot on the paper, and you do want to label it. So you either want to identify it as using its ordered pair name, or some other means, a letter, something to indicate which one it is. All right, so let's look at some examples. And we're going to do two things. We're going to graph it, and then we also want to identify the quadrant or axis. All right, so for example A, we have -4, 3. So starting at the origin, we are going to go 4 spaces to the left, and we are going to go 3 spaces up. And so we should be right here. I'm going to put my dot. That's a little off. I'm going to put my dot, and then I want to label. Now, if you want, we have letters over here indicating which point is which point. So if you want, you can label this A, or you can label it using the point name, -4, 3. All right, we want to identify where this point is, and so it's either going to be on an axis or in a quadrant. And this one is in quadrant 2. Remember that we start with quadrant 1 and we go counterclockwise. All right, the next point we have is -5, -3. And so again, we are going to start at the origin. We are going to go 5 to the left, and we are going to go 3 down because the 3 is negative. And so if we go ahead and plot this point, we get, it is right here. That's a little too low. We label, and again, you can either label this as B, or you can label it using the ordered pair. -5, -3. All right, this point is in quadrant 3. All right, example C, we have 0, 4. This means that we want to start at the origin. Remember, the first number tells you how far left or right to go, and because it's a 0, we do not move left or right. We want to go to our second number from the origin, and we're going to go up 4. So we should end up right here. We label. And just note, when you're doing these on paper yourself, no, you do not have to do both of these methods. It's up to you whether you want to use letters or you want to use the ordered pair. All right, now this one, we want to know whether this is, which quadrant or axis this is on. This is not in a quadrant. So you cannot sit there and say quadrant 1 and 2. That doesn't work. You can only be in one spot. You cannot be in 2 quadrants at the same time. And so we have that this is not in a quadrant, this is on an axis, and this is on the y-axis. Remember that left and right is x, and up and down is y. All right, and the last point we have is -2.5, 0. What this tells me is, starting at the origin, we want to go 2.5 to the left, and the second number tells us we do not want to go up or down, so we are just going to stay on this line. So we have our point D, or -2.5, 0. All right, so this point, where is it? Again, this is not in a quadrant. It is on an axis, and it is on the x-axis. All right, so that is plotting points in the rectangular coordinate system. All right, the last thing that we're going to talk about is solutions to equations in two variables. We haven't seen any equations, and graphing is going to be kind of this visual representation of when we look at equations. And we still have solutions. So, when we have equations that have two variables, our solution is going to be an ordered pair x comma y. And just like when we talked about equations in one variable, we do the same thing for equations in two variables. We want to plug the coordinates in for their respective variables and simplify each side of the equation. If you get a true statement, then the ordered pair is a solution. Another way that you can say this is it is a point on the graph. Otherwise, it is not. So let's look at some quick examples of this. Example A, we have y equals 3x minus 10. And just to remember for these points, these are x comma y. So x is 4 and y is 2. So if we go ahead and plug in these numbers, I want to replace y with 2. And I want to replace x with 4. From here, we want to simplify. Left side, nothing to do. On the right side, we want to do 3 times 4 is 12. And if we subtract 10, we do get 2. And is this a true statement? It is. So just a reminder that what were we asked to determine? I want to know, is 4 2 a solution? And it is a solution. All right, let's come over to the second point. We have -1, -4. Again, our equation was y equals 3x minus 10. And if we plug in, we're going to replace y with -4. We are going to replace x with -1. And we're going to simplify. Left side stays the same. On the right side, we get 3 times -1 is -3 minus 10. And if we combine that, we have same signs, so we are going to add and keep the sign. So is -4 equal to -3? The answer is no. And so -1, -4 is not a solution. All right, so this is an example of a linear equation. And just so you know, this applies to any type of equation. If we come to example B, we have y equals 3x squared. And it's the same thing. So we're going to replace our letters with our numbers. Again, x is -2, y is 12. And if we plug this in, we get 12. Our y equals 3 times -2 squared. We want to go ahead and simplify each side. So on the left, it just stays a 12. And on the right, we want to simplify using order of operations. So the first thing we want to do is square -2, which is -2 times -2 becomes +4. And now if you multiply 3 times 4, you get 12. Since 12 is equal to 12, this is a solution. All right, last one, we have -3, -27. And so if we plug this in, we get -27 equals 3 times -3 squared. All right, if we simplify, left side is done. We want to square -3. And if we multiply -3 times -3, we get +9. And if we multiply 3 times 9, we get 27. And is that equal to -27? And the answer is no. So -3, -27 is not a solution. All right, last example. Just so you know, we can have equations. There's no rules in terms of where variables have to be. Equations can be very basic looking. So for instance, this one here, we have all of our variables on one side equal 1, and that's perfectly fine. We still do the same thing. So we are going to plug in our values. We want to replace x with -2, and so we get -2 cubed. We want to replace y with 9, and we have equals 1. All right, if we cube -2, this is -2 times -2 times -2. That's supposed to be a -2. Here we can cancel 2 of our negatives. We have 1 left, so this is going to be negative. And if you multiply 2 times 2 times 2, you do get 8. We can go ahead and bring down the rest of our equation. And now if you do -8 plus 9, we have different signs. We are going to subtract, keep the sign of the larger number, and we do get 1 equals 1. And so -29 is a solution. All right, so that is solutions to equations in two variables. Now, one thing to note is when we talk about equations in two variables, notice that we are saying is a solution or is not a solution. All we can do is talk about this one particular point. You do not want to use the phrase no solution. When you use the phrase no solution, this means there is not a single point out there that will work in the equation. And that's just not going to happen. And same thing when is a solution. Is this the only solution? No. When you talk equations in two variables, there are an infinite number of solutions. Just like there are also an infinite number of points that are not solutions. In the next presentation, we are going to start by talking about, okay, well, if there's an infinite number, how do we find them? And then we'll go ahead and continue with our graphing.